Hello friends, this is Suresh and today we are going to learn about PyTorch tensor and PyTorch AutoGuard function. So before the PyTorch, I just brief about NumPy implementation of tensor. NumPy implementation of tensors like how to and we differentiate with the PyTorch tensor. So in the NumPy, if you want to create a random matrix, so just is a num dot random dot rand. So here the dimension I choose here n, d in, h, d out. So n is the number of the batch and d is the that is the input dimension and h is the hidden dimension and output is the output dimension. So as a input I create a matrix called x and as a output is y. So both are randomly created using the NumPy and this is randomly initialize the weight. So this weight w and w2 is the weight parameter that we have to like modify that we have to update during the training time. So weight code like is the connection in the neurons, right? So that called weight. So here for compute the weight and compute the loss and gradient everything, so I'm writing all the algorithm here in the numpys like that is equation called that ML equation that called z is equal to wx plus b, that equations. Similar here in the PyTorch, so similar in the NumPy like for creating random input and output and initialize the random weights. In PyTorch also just we have to import PyTorch. Similar like we have to import NumPy, so we have to import the PyTorch torch, and then similar the dimension we already in whatever dimensions of the matrix that we set same, and like np dot random functions here. So here and that called torch dot rand and input dimension, input din, and then device and data types. And similar like we have to initialize the weight, similar we have to do in the torch. So torch is the difference here, like NumPy use the CPU for the computations, but here we can select CPU or GPU. So for example, we want to GPU, so we have to put here GPU. If we want to use CPU, then it will be the CPU. So both we can do. So using the torch we can use CUDA, we can use GPU computations, GPU whatever. So that's the benefit, and a lot of deep learning and machine learning library available in this. And here like for the compute the loss and compute the gradient, we have to write everything. So here we are computing the loss function, and here we are creating compute the gradient, right, using the chain rule of the gradient. So everything, so here we, only the we updating the two weights w and w2. If we are increasing the hidden layer, right, then we have to like w1 w2 w3 w4 w5, then what we have to do, so we have to compute the gradient number by number. So it will so much complex if 100 of layers there, so 100 times we have to write, so it's too much complex. So for that we need to search for the problem. So PyTorch that torch have capability to compute all these things backward. So that called AutoGuard function. So PyTorch have AutoGuard functions to compute the gradient all things. So in the PyTorch, like what difference in AutoGuard and in generally this difference here. So no need to compute, no need to write all things for the compute the gradient. I will show here. So all things we defined same, like whatever required for that random function, initialize the weight, everything. So and y predict. So right now we are writing the y predict. So it's similar like here that y predict, this y predict, and after that loss and compute the gradient, just we have to write only this line like loss dot backward. So loss dot backward automatically we will do all the computation and all the gradient everything, right? So for that we have to specify which variable we want to like we want to differentiate, which variable we want to differentiate and compute the gradient. So we have to do like if require grade is equal to true, so internally by default require grade equal to false, it will internally by default it will false. So if you are not writing required like true, so it will consider that this is not this not consider as a for graded computations. So only the two parameter, that connection, that like update the two weight parameter, we need to compute the gradient. So we have to specify required gradient equal to true. So here and that two parameter, then later we can update. So after computations, we are getting grade underscore w1 and grade underscore w2. So this grade underscore w1 and grade underscore w2, so internally it will compute and we will get grade underscore like w1 dot grade and w2 grade, and we are updating weight here. So here similar like we are updating weight after compute the gradient. So no need to all things required, so just w dot grade, w2 dot grade, and we are updating the weight here. So all things are handled by the closed dot backward functions. So this is all about AutoGuard functions. So AutoGuard functions have capability to compute the gradient, everything. So this is all about basically if we want to write fundamentally how PyTorch will work, and fundamentally how we can write a algorithm and like forward and backward propagation, both forward propagation and backward propagation fundamentally. But all things like if you write W1, W2, W3, so if you want to write CNN model, CNN, yeah, RNN, whatever. So PyTorch have different module for that called PyTorch NN module. So next session we will discuss about PyTorch NN module and how to use, and we will do the basic, create the basic layer, basic forward pass and backward pass, and we'll see the results. Yep. So this is all about it. Thanks joining, guys. Yeah. Yes. Yes. So this is the NumPy library, right? And yes. So in PyTorch module, we are not using the NumPy library. So I am just explaining how NumPy library compare with the PyTorch. So NumPy library not like we can't use for the deep learning and machine learning purpose, because of that is in deep learning generally we require GPU. So NumPy library not support GPU. So I'm just explaining, like if you familiar with NumPy, so it's similar like NumPy PyTorch also. So I think all things similarly, whatever required. So no change, nothing. So if you know NumPy, then easily you can like pick up that PyTorch also for machine learning, deep learning algorithm. Okay. Right. Other one also like that PyTorch have that NN dot module, right? So NumPy don't have such capability like algorithm also for machine learning, deep learning. So but PyTorch have lot of library for machine MLDL. So NumPy not that have. So NumPy only have some scientific calculation library, mathematical calculation library, numerical computation such. So lot of support available for MLDL algorithm. Yeah, we can use. Right. So sometime we use for basic operation. Sometime we will go for basic operation NumPy, and that NumPy tensor can be converted in the PyTorch tensor. So this NumPy X and Y can be converted in the PyTorch. So in basic operation we can use NumPy and then convert in PyTorch tensor. So like torch dot convert. So learning rate is the machine learning algorithm. So this is learning parameter, how your model will learn. So rate means like how gradually it will learn. It will learn fast or slow. So we have to specify the learning rate, like it will learn step by step, not directly. If you start learn directly like bigger step, so might be it will miss the some parameters. So learning rate decide how we are learning.
So it is fixed always learning rate equals to 1 e minus 6.
It's not. It is not fixed. So it is not fixed. It is the experiment. Like some people, like for example, some child, yes, some student learn fast, yes, some student learn slow, right? So it depend on the data. It depend on the what we are training to our model. It depend on that. So we have to check every time how model learn. So if model unable to generalize, then we have to do learning rate very less. So it will learn small.
So how do you calculate this learning rate?
So it's a like hit and trial. We can't calculate. So hit and trial. We just put some number there and we try. It's learn or not learn. If not learning, then again we change. So it's the hit and trial. So it's not fixed. Like we can't say okay, this is your learning rate.
So there is a learning rate equal to 1 if it's fixed, but you are given trial method is minus 6. Then after that 1 e minus 5 minus.
No. This is the one is the fixed. For next trial we have to change like 1 E7 whatever.
So I think you have learned according to this learning rate 1 e minus 6. Then
Uh,
again you have to learn the model learning rate equal to 1 e minus 7 like that.
like that. For example, this learning rate not work. So what? For example, I'm training a child. Ki this is cat and this is dog, and I put this learning rate. But child unable to run using this learning rate. Then I have to reduce the learning rate, and will check is learning or not. If again not learning, then again I will change the learning rate. Yes. Yeah. Thanks for questions.